Hello, this is Mike Bonis, and I'd like to respond to a question about how we can design an experiment that will use the minimum amount of resources to apply our practical knowledge of a problem. It will lead us to using custom design of experiments in JMP in order to minimize the amount of runs necessary. We start with a planning sheet that describes what's the objective of the experiment, what the response is, and what the factors in the experiment will be. This situation is one where we're doing a screening experiment, maybe characterizing a little bit. We are at the early learning phases of trying to understand what factors are affecting the response. There are quite a few factors. We have 8 factors in our list, 7 of which are 2-level factors, one of which is a 3-level factor. At this point, we'll assume that the team has reduced the number of insignificant factors to this level and has to relearn about these factors experimentally. It wouldn't be helpful to eliminate factors or to change the 3-level factor to a 2-level factor. We can go to JMP at this point and find out what are the experimental design options. In JMP, we've created a table with those factors and those levels, and now we're ready to design an experiment. Let's examine what would happen if we try a full factorial experiment. If we load those factors into this dialog, we'll see that all 8 of them are there. If we ask JMP to construct the full factorial array, it will end up with 384 runs. That is not going to be affordable. And not only that, but an experiment of that sort will estimate effects that are likely to have no response. It would be expensive and wasteful. Our experts think that beyond these 8 factors and perhaps their their two-way interactions, there won't be much else to see. This is not the right design for this state of knowledge. We're in the screening stage of our problem solving, so let's try a definitive screening experiment. It seems like it's got the right name, but we're going to reveal, once we load those factors, that the definitive designs are for 2-level factors. And JMP is advising us to use a custom design. That will be the next step. We can go to the custom design dialog and load those factors. The 8 factors are listed here. In this situation, to estimate those 8 factors plus the grand average, we're going to need a minimum of 10 runs, 10 treatments. The reason for 10 is fairly straightforward. Every factor that uses 2 levels needs 1 degree of freedom to estimate it. We have 7 of those. This 3-level factor H needs 2 degrees of freedom. That brings us up to 9. We'll need one more to estimate the grand average, and so that takes us to 10. We know that by the experience of our experts, some interactions are likely to be important. We'd like to estimate those effects. When we tell JMP we would like to look at two-way interactions, it will add them to the list of possible terms in the model. That will require a minimum of 45 runs, 45 treatments, to estimate those effects. The reason for 45 is every time we add an interaction between two-level factors, that's one more degree of freedom necessary. When we add an interaction between a two-level factor and our three-level factor h, that requires 2 degrees of freedom. As we add those up, we get to 45. Now, this is the beauty of the custom factorial design dialog in JMP. If we know by prior knowledge or by risk-taking that the EF interaction is not going to happen, it's just physically impossible, we can tell JMP by choosing this menu here, only estimate it if possible, meaning don't bother to add a degree of freedom for that factor. We just went from 45 down to 44 because we took out an interaction between two-level factors. If we take out something that interacts with H, we reduce the size by 2. If we believe that factor H doesn't interact with anything, we really only cared about its main effect, we can cherry pick everything that interacts with H. Say if possible, and now we're down to an experiment where only 30 runs are necessary. In a separate video, we'll discuss tools for prioritizing the likely interactions, and in a separate video, we'll have a discussion on why we might choose something other than the minimum, given that in this situation we think this is a wise choice of factors and interactions, and we'd like to minimize. Now we press the Make Design button. We wait for JMP to do some optimization to try to find the 30 treatments that give the best design configuration. And there are the 30 runs that we would build in our experimental sequence as shown here. We can look at diagnostics, we can consider possible alternatives, we can play with the design until we found a satisfactory combination, and then we're ready to run the experiment. That's how to create a custom design in JMP.